The beam shown in the figure carries a uniformly distributed load of W on overhanging BC. The beam is constructed of a wood beam that is reinforced on its upper surface by a steel plate. Assume that the allowable bending stress of the wood and the steel are 9 MPa and 165 MPa, respectively. Determine the largest acceptable magnitude of the distributed load W. Okay, the sizes have been given. Okay, this is a typical design problem, and we need to determine the maximum loading that is applied on this overhanging part of the overhanging beam. Okay, so we need several steps. So the first step, normally we start from a loading and determine the shear diagram and bending moment diagram, etc. Right? But we don't have the value of the loading, so we just assume that W is W. Right? We assume a unknown. Right? We just carry this variable in the calculations. So then we can draw the V and M diagrams. Right, based on that, we select the maximum bending stress, bending moment. Right, then we determine the Y bar and I, and compare the calculated maximum stress from maximum moment times C over I. Compare this one and the allowable stress, right, to solve an equation. Right, those are the general steps. Then let's solve it step by step. Okay, the first step and second step, I will just skip it. I will skip them. Okay, since this is easy, simple enough structure, so you can just do that from the beginning. Free body diagram, right, to equilibrium equations to determine reaction forces. Then V diagram, then M diagram. Right? Those are the general steps. But anyway, we have determined that from here, so we have determined the reaction force at A, reaction force at B. Right, then we will draw the V diagram and then M diagram. So we have determined that the maximum bending moment equals this area, right? It is negative WA square over 2. And here the A is 1.25 meter, 1,250 millimeter. Okay, so this one will be negative 1250 square W over 2. The unit will be Newton millimeter. Okay, so the third step, we will transform the wood into steel. Okay, wood into steel. Okay. So the steel part will not be changed. The steel will not be changed, but the wood will become much thinner, right? So this shape will become this shape. Okay, the steel plate, the sizes will not be changed, but the width of the wood after changing to steel will be changed. We just need to determine this size. Right? So the N will be E wood over E steel. over 200, 0.06. Right, so the new width when wood is transformed into steel will be 150, the BW here, 150 millimeter times 0.06. This will be 9 millimeter. So this is the size here, only 9 millimeter. So the height, DW here is 280, and the TS 6, BS 230. Okay, knowing these sizes, you can just calculate the Y bar and I. Right. So again, I will skip this. Okay, I will skip this. You can try to do these calculations by yourself. Just 2 equations, 2 tables. Right. So the Y bar is 190.6 millimeter. I will be 34.7 million millimeter to the fourth. Okay, then in the fourth step, we can calculate the maximum stress in steel. This will be maximum bending moment times Y max or C top. Right, so over the I. This will be 1250 square W over 2 times the Y max. Y max is 280 plus 280 here plus 6 minus Y bar, right? Minus Y bar. The Y bar is 190.6, right? Over the I, 34.7 million. So here we will get 2.148 W. And this one is not larger than 165, right? So we can derive that the W has to be not higher than 76.8 Newton per millimeter. Okay, in the same way, we can check the other part, that is the wood. Right, the maximum stress in wood will be N times, right, this is the part that you are converted. You have converted the wood into steel, so the wood is a fictitious part, right? So we need to multiply it by N times the maximum moment times Y bar, right? This wood is on the bottom, right? It's on the bottom, so this is the Y bar over I. This will be, so I skip the calculations, okay? This will be 0.257 W. Okay. the allowable stress is 9, so this should be not higher than 9 MPa. So the W is not larger than 35 Newton per millimeter. Okay, so now again we get two results. Right? Cannot be larger than 76.8, cannot be larger than 35. So the final result, the W should be no larger than 35 Newton per millimeter. Okay, so this is the final design report. But as we mentioned, you will have another choice. You can convert the steel into wood. You can convert steel into wood, right? But if you do that, you can see what will happen. Right? So the wood will not be changed. Right? Steel into wood. This is also doable, but you can see that if you do this conversion, the wood will not be changed, but the steel will become wider by a factor of so the N will be 200 over 12. This will be larger than 16, right? So the size of the steel will be, I cannot accommodate it, right? I can't accommodate it. It will be something like this, right? It's also doable, but it's just ugly, okay? So it's not recommended in this example, okay? Just the first solution is perfect. Okay? It's wood into steel. I convert wood into steel.